Hello everyone. Today we will discuss salinity, which is a topic from oceanography, factors affecting salinity, and then distribution of the salinity. Now first thing is what salinity is. We say seawater is brackish to taste because it contains dissolved salts in it. This dissolved salt give the property of salinity to the seawater. Now, if we define this salinity, we say salinity is the number of dissolved salts in water. And if we say this water, it is your sea water or ocean water. Number of dissolved salt in water. It is expressed as the total number of dissolved salt in 1000 grams of sea water. This salinity may vary from place to place. Some places salinity is less, some places salinity is more. Average salinity or average seawater salinity is 35 ppt, which means parts per thousand. The symbol to represent is this. It means if we take 1000 grams of sea water, in that 1000 grams of sea water, there are 35 grams of dissolved salt, which are in different proportion. In the given figure, if you see, this distribution of the salts is given by Dittmer. He said there are around 47 different salt dissolved in sea water, and some of the major salts are, which are reflecting in your screen. If you see, there is a name of the salt, quantity per 1000 gram of water, and percentage of the salt. The first salt is sodium chloride, which is 27.213 grams, and the percentage is 77.8. It means in 1000 grams of sea water, sodium chloride is dissolved 27.213 grams. Similarly, it is your magnesium chloride 3.807, magnesium sulfate, calcium sulfate, potassium sulfate, calcium carbonate, magnesium bromide. Now, if you add all these salts, it comes to be 35. It means in 1000 grams of sea water, these are the different salts dissolved in different proportion, which comes equal to 35 grams. Now, it means that average salinity, if I say, is 35 ppt, it means some of the ocean this salinity will be more than average, some can be less than average. If I take an example, Red Sea, if we talk about Persian Gulf, the salinity here varies between 31 to 41 ppt. Lake Van or Dead Sea, here salinity varies 330 ppt to 20 ppt or more than that. Similarly, if I take an example of Baltic Sea, where salinity is 7 to 8 ppt. So thus in the oceans, as we move from one place to another, salinity varies from place to place. This is the average salinity, 35 ppt. Some places it can be above the average, like these examples, and some places it can be below the average. As the salinity is highly variable, thus we say the total amount of the dissolved salt is variable. However, relative proportion of the salt or the elements, they remain constant. It means salinity can vary, but the proportion of the salt, that will remain same. Now, one of the question is, why salinity is important? Salinity is important because it determines the density of the ocean water. It means when salt is added to the water, as it becomes solvent, it increases the density of the water, thus water will tend to sink down. Second, it determines the distribution of marine flora and fauna. For example, if I say corals, corals can survive. For the growth of corals, they require certain degree of salinity, minimum to maximum. We say minimum is 27 ppt, max is 33 ppt. It means if salinity will decrease or increase beyond these limits, corals will not survive. So that's why it helps us in understanding the distribution of marine flora and fauna. Third, it determines the thermal expansion. By elevating boiling point, it also determines the movement of ocean currents. This we will discuss in detail in the topic of ocean current movements. So here we will remember, due to the salinity difference in the oceans, at the surface water moves from low saline area to high saline area, and at the bottom it moves from high saline area to low saline area. It is simply in terms of your osmosis. This part we will discuss in later topics. Now we will address the second part, which is factors affecting the salinity. There are a lot of factors directly indirectly related to each other which affect the salinity of the ocean water. If we pick this first factor, which is latitude, it means insolation is maximum at equator, thus temperature will be also high there, and temperature is directly related to evaporation. So more the temperature, more will be the evaporation, and thus higher will be the salinity, because in the process of evaporation fresh water will get evaporated and the concentration of salt will increase. Second factor if we take is precipitation. It means higher the rainfall, addition of fresh water, will be more, the salinity will decrease. If we take general example, salinity should decrease from equator to poles with the factor of insolation. But when we add the precipitation factor there, equator rainfall is also high. Due to high rainfall, salinity will slightly decrease in equator, and just north and south of equator in tropics, salinity will be slightly higher. Then if we come to the transparency, same. If transparency is more, insolation will be higher, thus temperature will be more, evaporation will be thus more, and salinity will be again higher. Same factor if we correlate it with equator and tropics. Over equator, evaporation is not that active because of the presence of clouds and water vapor. Thus, they obstruct the flow of incoming solar radiation. Slightly temperature decreases there at equator, due to which evaporation will get affected. But in tropics, in comparison to equators, due to active evaporation, because transparency is there more, evaporation will be more, salinity will be higher. Then if we come to the next, influx of rivers. If the influx of river is more, higher the influx, addition of fresh water will be more, the salinity will decrease. This is the reason around the river mouths salinity is very less. Another factor is melting of glaciers, ice flows and icebergs. And iceberg. As they will melt, they will add again fresh water. The salinity will decrease. One of the reason in poles why salinity is less. In poles, insolation is less, evaporation is less, salinity is less. Second, due to melting of the glaciers, they will yield the fresh water. Because of that, salinity will decrease. Now, apart from that, there are other factors, like if we go with wind movement. In general, we say more the wind movement, more is the evaporation. More the evaporation, more will be the salinity. Because we know that wind movement can replace the saturated mass of air with unsaturated, thus evaporation can be more. But let us discuss it bit in detail. This wind movement will influence the salinity. If we take an example of the tropics first, assume this is tropical sea and this is surface water. Insolation is high in tropics, thus the surface water will be warm. Due to warm surface water, evaporation will be high, due to which salinity will be higher. Now assume if winds are moving, these winds will drag the surface warm and saline water from this part to this side, thus here salinity will increase, and here due to upwelling of this less saline water, salinity will decrease. Now if we take an example, in Africa, this is western coast of Africa and here this will be eastern coast of Atlantic. And here this will be your western coast of Atlantic and this will be eastern coast of continent. Salinity is more at the surface in tropics here as well as here. When these trade winds will move, similarly according to this figure, they will drag the surface saline water to this side, so here salinity will increase, and from the bottom here less saline water will upwell, so salinity will decrease here. Thus we say in tropics, eastern margin of ocean is having less salinity in comparison to west. Similarly here, westerly winds will move, so they will drag the warm water. The salinity will decrease here in temperate zone on the western margin of the ocean, and salinity will increase here on the eastern margin of the ocean, or we can call it west of continent. So if we talk about in Europe, western coast has more salinity, and if we talk about North America, eastern coast along Labrador, along your Newfoundland, salinity is less. So this is how wind will affect the salinity. Second is ocean currents. Ocean currents will also influence the salinity. Due to the movement of oceanic currents, water moves from eastern coast to western coast. Warm water has more salinity. Thus, As this ocean water is moving from east to western coast of the ocean or from the west of the continent to the east of the continent, it drags the whole salt to this side. So salinity here increases, here it decreases. Now we can take another example. The salinity around the Labrador Sea is less, or Labrador coast is less, but salinity around Norway, North Sea, it is more, because there is one oceanic current which is called as North Atlantic Drift. North Atlantic Drift is the extension of Gulf Stream which is moving under the influence of the westerlies. So it is a warm current. As warm water can hold more salt, thus it increases salinity on the western coast of Europe. Another factor is effect of the adjacent landmass. This factor is predominant in tropical areas. Tropical waters, especially in those tropical waters which are partially covered or partially enclosed by land. For example, Red Sea or Persian Gulf. In summers, sunlight falls in both. If I give an example, this is Arabian part, or if I say this is African part and this is Red Sea. If it is Iran, this will be Persian Gulf. This part is your Africa. Now in summers, sunlight fall both on land as well as in water. We know the specific heat of water is more, so it takes time to heat up, whereas the landmass will become heated faster. Thus, this land will transfer some of the heat to water and the temperature of these water bodies will increase. As the temperature of these enclosed water bodies will increase, evaporation will increase, thus salinity will be high. Similarly, regions of subtropical high pressure belt where anticyclonic conditions prevail. If I am saying this is equator, this is 30 degree. The air which rises there will start sinking here. As soon as this air is sinking air mass gives less rainfall. Thus, addition of fresh water is less, so salinity will be higher. So, these are some of the factors which will affect the salinity.